Hello everyone, this is Unit 2, Lesson 6. I can describe a pattern of change in tables and graphs to determine if the linear function is a direct variation by using slope and proportional relationships. So the first thing that we're going to do is just take a look at the entrance slip, which is to do now. Which line represents the best fit for the scatter plot? So remember, a line of best fit is supposed to be going through all the center of all of the points. So A looks good to me, but let's check out C. C is definitely incorrect because you're supposed to draw a trend line that is going through all of the center of all the points. B is incorrect. You would not have that. And D is, it looks like it's okay, but the thing is that the trend line is a little bit too far up and above the points. So A is your answer. That is the best trend line, right? The best fit. So a direct variation, we know what this is. The direct variation is when y directly is proportional to x. A direct variation equation from the 7th grade, or you might have known before, is y equals k times x. It's similar to y equals mx plus b, where m is the slope, right? M is the slope in y equals mx plus b. M equals k in that kx, and b is 0. B is 0 because the y-intercept is 0. Remember, a direct variation is when a line goes through the center of the origin, which is at 0, 0, and continues on that way. It has to be linear, and if it's a linear function, a linear, linear going through 0, 0, that means it is a direct variation or proportional relationship. Direct variation on a graph looks like this right here, where the line goes straight through the origin. The y-intercept is 0. In equation, the y-intercept must be 0, so it looks like kind of like y equals 3x, y equals negative 5x, y equals 1/2 x. Anything like that is a direct variation. A direct variation in a table, in order for it to be a direct variation, it should all have the same k value, which means when you divide y and x, it equals k. So if you divide 6 and 3, it'll equal 2. You divide 10 and 5, it'll equal 2. They vary in proportion with each other. So that means like everything is in proportion. So if you divide y and k, it'll equal the same, y and x, it'll equal the same thing, which is the constant of variation, which is k. All right, so 14 divided by 7, if you take 14 and divide it by 7, it'll equal 2. 18 divided by 9, it'll equal 2. You can continue this table if we really wanted to, and you could just go, say, if you were skipping by 2's with the x, obviously this is 22. All right, 22 divided by 11 would be 2. And you can continue on, all right, 13, 26. And that's a direct variation. A direct variation, if it's not a direct variation, when you divide y and k, y and x, you will not get the same k, the same constant. So if like you divide 6 and 3 and you get 2, and then the next one is like 10 divided by 6 and you don't get 2, then you know it's not a direct variation. It does not go through 0, 0. So it says launch on your own. Write a function rule equation. A function rule is just y equals mx plus b for the linear function with the points 0, 0, 2, 5, 4, 10. So we're talking about a function rule. So we're just going to say, okay, a function rule is y equals mx plus b. That is a function rule, where m is the slope and the b is the y-intercept. So we're taking a look at this. If I want to get my m, my slope, I'm going to use m equals y2 minus y1 over x2 minus x1. So I'm going to label, I'm just going to label x1 and y1. And remember, you only need 2 points. I can use any 2 points to figure out slope. So I'm going to use the first 2 points because I like using 0 as a point because it's easy to subtract. All right, so my y2 is 5, my y1 is 0, my x2 is 2, and my x1 is 0. So I can do this in my head. 5 minus 0 is 5. 2 minus 0 is 2. I'm going to leave it like this, 5 over 2. I could really put this into 2.5. So I'm not graphing, so I'm just going to put it as 2.5. So my m is 2.5, but I need a b. And remember, the y-intercept is where it crosses the y-axis. So whenever x is 0, the other number is the y-intercept. All right, if you make a little bit of a sketch on the side here, 0, 0 is obviously right here. I'm just making my 0, 0 is right here. 2, 5 would be here. 4, 10 would be here. A straight line would be that way. And it crosses at 0, 0, so the y-intercept is 0. So my b is 0. So with a y-intercept of 0 and a slope of 2.5, my equation, my function rule is y equals 2.5x, and that's it. Is this function a direct variation? Yes, it is. It travels through 0, 0. So anything that goes through 0, 0 is a direct variation. So explain your answer. Yes. And that's it. The linear function crosses through the origin, so that's why it's a direct variation. How could you tell? By looking at the equation. Well, you could tell by looking at the equation, y equals 2.5x, that the y-intercept is kind of like, looks like it's missing. All right, so if it looks like it's missing, it is 0. And if the y-intercept is 0, that means it's a direct variation. So that's how you can look at the equation. The y-intercept, the b, is 0. So you see that it's y equals 2.5x. That's the y-intercept of 0, and that's a direct variation. How could you tell looking at the coordinates? Well, the coordinates have 0, 0. If you know it crosses at 0, 0 and it's linear, it tells you that it's linear, that means it's a direct variation. Without finding the function rule, which strategies can you use to tell this direct variation? We just use 2. So this would be the first strategy, and then this would be the second strategy. All right, finding the slope, getting that slope, and then getting the fact that the slope remains the same throughout the 2 points. And then you could try to figure out if the slope is the same throughout these 2 points. Then you could prove it's linear, and then it goes through 0, 0. If it's linear and goes through 0, 0, it is a direct variation. All right, create 2 equations that are linear functions but not direct variations, right? So no direct variations. So that means it cannot cross through 0, 0. So we have an equation of a line. So the equation of a line is y equals mx plus b. So if at any time that you want to just stop and just put down the equations, just go ahead, stop the video, press pause, and then just put down 2 equations that you think are linear functions but not direct variations. So we're just going to start. Remember, y equals mx plus b. You could put any m, you could put any b. So I'm just going to put y equals 3x minus 10. This is a line that has a slope of 3 and a y-intercept of negative 10. It does not cross through 0, 0. And then y equals 2x minus, I put plus 5. This is a positive slope, goes up from left to right, has a slope of 2 and a y-intercept of 5. These are 2 linear functions, but they're not direct variations. They do not cross 0, 0. create two equations that are linear functions and direct variations. So you know that the y-intercept must be 0. So you could use any slope that you want. Y equals 1/2 x plus 0. You don't have to put the plus 0, but it goes through 0, 0 if you leave the 1/2 x. And then y equals -5x, and you're finished. All right, just remember, -5x goes down from left to right. It's pretty steep, right? Steep, down from left to right, and crosses through 0, 0. So create two equations that are literal functions and parallel to each other. So linear functions, so I'm going to use that first one that I put down, y equals 3x minus 10. So it has to be parallel. Remember, parallel lines have the same slope and different y-intercept. So if I put y equals 3x minus 10 down, I would have to put y equals 3x, and I could leave y equals 3x, or I can just put a y-intercept in, plus any y-intercept except for a -10. So these lines here are parallel to each other because they have the same slope and different y-intercept. Just remember that, all right? Same slope, different y-intercept. And that is about it there. All right. What makes a graph a direct variation? So what makes a graph a direct variation is when it crosses through 0, 0, when it crosses through the origin. So the line crosses through 0, 0. Right? So when a graph crosses through 0, 0, you know that it is a direct variation. Okay? So just remember, create an equation that are linear functions but not direct variations. You have y equals mx plus b. You have create two equations that are linear functions and direct variations. The y-intercept must be 0, so that's why it's y equals 1/2 x, y equals -5x, and create two equations that are linear functions but parallel. They have to have the same slope and different y-intercept. Same slope and different y-intercept. If it has the same slope and different y-intercept, you are parallel. These are parallel lines. All right, and that's it. What do parallel lines have in common? We could put this and just go ahead and clone it, if I can. What do parallel lines have in common? Yep, same slope, different y-intercept. All right, they have in common is the same slope. All right, so it says try this, state test prep. So which coordinate pair is on a line with a zero slope? Zero slope. So a slope of 0. Just remember, a slope of 0 is a horizontal line. So if you really don't want to go ahead and figure out the slope, you can actually just kind of plot these points. See which one is horizontal. If it's horizontal, that's the 0 slope. So, but other than that, we're just going to go ahead and figure out the slope. So x1, y1, x2, y2. And we're going to go and put m equals y2 minus y1 over x2 minus x1. M equals, we're going to put the minus sign, we're going to do 4 minus a -4. So that's 4 plus 4. 4 plus 4, you're not going to get a slope of 0. Whatever 10, it's 10 minus 10. So 10 minus 10 is 0. So this is 8 over 0. But that is not 0. Please don't get fooled. That is undefined. So that's an undefined slope. So that one doesn't work. So let's go to the next one. Remember, the top of your fraction has to be 0. So I'm not going to keep on writing the formula down. You know it's y2 minus y1. So y2 is 0. y1 is 6. I could stop right there. I know that the top part of this is going to be negative 6. And 0 minus 0 is 0. So that means that it is undefined again. That's two undefineds. By the way, undefined lines are vertical lines like that. So if you graph these, you would actually see that they were vertical. We still haven't gotten to the 0 slope yet. So we have this. So we have 4 minus 4. That looks like 0 on the top, which is what we need. Negative 11 minus 3, which is negative 14. I'm going to stop here because this is the m of 0. So which one has a 0 slope? C does. C does. All right. Going on to the next, by the way, it says you always have to solve for y. But there's an easy way of showing which one is a direct variation. Just remember, a direct variation, it does not have, it's like y equals k times x. All right, this k is your m, and the y-intercept is always 0. So it would look like this in mx. I know the plus b is supposed to be there, but the plus b isn't shown because, remember, a direct variation is when b is 0. So which one of these do you think, if we're just guessing, which one is a direct variation without actually solving for y, which one would you guess is a direct variation? The green or the red? If you said the red, you're correct. This is the direct variation. Even without solving, you could tell that this is going to be the direct variation. I'll prove it. Remember, you must know how to solve these for y. Minus 4x, and we're going to solve this one for y. And we have three numbers here. We have 4x, the 10y, and the 20. So we know that right now that when you solve this, you're going to get a y equals mx plus b that has numbers for each one. So we're going to have 10y and negative 4x and a plus 20. Then to get y alone, to solve for y, we have to divide by whatever is next to the y, because this is multiplication, 10 times y. So that means you have to do the opposite of multiplication, which is division. Negative 4 over 10 is negative 2 over 5 when you reduce it. And then 20 divided by 10 is 2. So the slope is going to be negative 2 over 5. And the y-intercept is going to be 2. So that is not a direct variation. But let's talk about this one. Remember, solving for y. Get the slope and the y-intercept. Get the y alone. So we're going to subtract x on both sides. We're going to subtract x on both sides to start to get the y alone. That's what I meant to do right there. And we are going to put 10y down equals negative x. And that is a negative 1x. I don't want to get anybody confused. Divide by 10. This is y equals negative 1 over 10x. That's what this is. Negative 1 over 10x. And this is the direct variation. Remember, the slope is negative 1 over 10. And the b is 0. That is your direct variation. Which one is the direct variation? We're going to say that the red dot, x plus 10y equals 0, is the direct variation because it crosses through the origin. So we're going to say that the x plus 10y equals 0 is the direct variation because there's a y-intercept of 0. and it is a linear function. Remember, it is not enough to have a y-intercept of 0. It has to be linear. So the way you figure out if it's linear, if it's in that y equals mx plus b format, it is linear. It's straight line, goes through the origin, direct variation. Write an equation that is parallel to the direct variation. So I am going to put y equals negative 1 over 10x. That is the direct variation. To write something parallel, it has to have the same slope with different y-intercept. So I am going to put y equals negative 1 over 10x, same slope, different y-intercept. Doesn't matter what the y-intercept is. It cannot be 0. It has to be some other number. So these are parallel, same slope, different y-intercept. So these are very, very easy. Does the graphed line below represent a direct variation? And you're going to put no. And it does not. Go through. The origin. And you're going to put yes. Right there, it goes through the origin. The line goes through the origin. Yes, it is a direct variation. And you have to put y because it is a linear function that goes through the origin. And that is it. Find the equation of each of the functions listed above. So we are going to find the equation. So this is very easy. We need two things. So we have y equals mx plus b. We need the m, and we need the b. I'll always look for the b first. The b is 2. I'm going to pick another point. I usually pick the x-intercept along with the y-intercept, if possible. If they're perfect points. When I say a perfect point, an integer point, a whole number. So we have 1, 2. That's going down. It's negative 2. This is positive 2. The rise over run is negative 2 over positive 2. That is a negative 1. So the equation of this line is negative 1x, which is negative x, plus 2. Equation of the line, not a direct variation. So now we're going to pick another point right here, another nice point there. We're going to go ahead and create that little triangle. Remember, we need the m and the b. The b is 0. Right there, direct variation. This is 3. This is 1. The rise is 1. The run is 3. Y equals 1/3 x. Not plus 0, just leave it. All right. A lot of people say, get confused and put 3 over 1. No, rise over run. Rise over run. We found the equation of each one, and we are going to move on. Which equation is not an example of a direct variation? Not an example of a direct variation. So 3 of them are direct variations. 1 of them is not. So this right here, what's the y-intercept? The m is 5 over 16. By the way, it doesn't matter what the slope is, but the b is 0. So this is a direct variation. We're going to put dv. The m is 4. The y-intercept is 0. This is a direct variation. We're going to put dv. Cancel. They're looking for the one that's not a direct variation. This m is negative 9. The b is 0. This is a direct variation, put in dv. This m is -7/3. The b is 1. This is not a direct variation, not. This is the one they're looking for. A is your answer. Which equation is not an example of a direct variation? You're looking at it, A. Which equation is a direct variation? Let's take a look. Is. I'm going to put m. First off, the m really doesn't matter, but remember, it has to be linear. So proving that this m stays constant throughout is like kind of proving that it's linear. But the b is the really big thing. Is a b 0? No, it's not. This is not a dv. It goes through at 6. You see all of these numbers. I'm not going to solve it. But you see all of those numbers. We're going to have a y-intercept that is not 0. Right? We're going to have a y-intercept that's something else. You would subtract 6x on both sides. Then you would divide by 4. And most likely, you would get like a 2 for a y-intercept. So this is not a dv. You're looking for the one that is a direct variation. Here we go. M equals 1/2. And B equals 0. If B equals 0, this is your direct variation. We could circle C, dv. And again, you have 3 numbers here. So you would subtract the 2x on both sides. You'd get 3y equals -2x minus 9. Then you divide by 3 on both sides. And you know what happens. You have a y-intercept that is not 0. And this is a linear function that is not a dv, direct variation. So the answer is C for number 2. All right, so we're going to start graphing here just a little bit. And let me just mess with the, hopefully that works out. That works out well. We have John charges $40 per hour as a pool cleaner. Create an equation based on the information above and let y equals to John's total pay. All right, so we're going to put that equation down here. I didn't leave any room up here, so that doesn't make any sense. We're just going to put this down here, and we're going to put y equals. So we have to have the m. So anytime that you have the word per hour, usually means that this is the m, this is the rate that John is charging. So 40 is the m, so we're going to put that 40m, 40 equals m. And then there's the b, the y-intercept, the initial value initially. When John works 0 hours, he's getting 0 pay. When he works 1 hour, he gets $40. When he works 2 hours, he gets $80. So we're going to start this out by putting that these are hours. Remember, X is always time, and Y is money. All right, those are dollars. So we could put hours here and money here. So let's create this equation. We have a B of 0 because he gets paid nothing. So 0 hours, $0. So what's that equation? Y equals mx plus b. We have the m of 40 and a b of 0. So it's y equals 40x. If you put plus 0, it's not wrong, but we don't need it. It's plus 0. Like, it doesn't add anything to it. So you leave it like that. This is y equals 40x, a direct variation. It has 40 as a slope and has a y-intercept of 0. So we are going to go ahead and just put in 1 hour for 40, 2 makes 80, 3, 120, 4, 160, and we'll leave it off at 5 200. All right, so the M equals 40 over 1. Remember, when you're graphing, you put your arrows next to your rise over run. Always put the 1 underneath that whole number, because you have to just show that, hey, I'm going to rise 40 and run 1. So go ahead and put 0 here, 1, 2, 3, and go up by 1s. This right here, this is going to be a little, question mark. Remember, this is money. So how much does John make in an hour? Does he start with anything? Is there initial value of anything but 0? The initial value is 0. So we're starting with 0. But how much does he make then for 1 hour? He makes $40. So that's what you're going to put as the first number. Then when you're jumping up by the slope. A rise of 40 is 80. A rise of 40 is 120. And you just keep on going like that. And remember, when you're putting your numbers, put the numbers right next to the line. That. 320. I'm trying to write as best as I could. 3, that is not right. 360. 400. 440. 480. 520. 560. And then you should be up to that 600 right there. So think about it. When John works 0 hours, how much did he get paid? Look at the table, $0. So that is your first point. And I want it to be in blue, and it is in blue. Then 1 hour, a rise of 40, a run of 1. A rise of 40, a run of 1. And you just keep on going like that. Rise of 40, run of 1. Just like that. Get your ruler. Connect those points is the straightest line as possible. And you are going to put the arrow there, and you're going to put the equation. You're not going to forget to put the equation on the line. It has a slope of 40 and a y-intercept of 0. You see how it starts. Is this a direct variation? Yes. Y equals 40x is a direct variation. What is the initial value? The initial value is the y-intercept. The initial value is the y-intercept. What was the y-intercept? Look at the y-intercept. It's right over here. Don't get confused. It's right there. What is that y-intercept? That y-intercept is 0. What is the initial value? B equals 0. That is it. Done. Finished. Right? You do not need a break because you're going up by 40 and then you're continuing up by 40s. All right? So you don't need a break there. And that is everything. All right, so we are going to go and try another one. Fran charges a $30 hiring fee. So we're going to go right there. And 50 cents per balloon animal. So we're going to create an equation. So the M, the slope, the rate, is per balloon animal. So 0, it's the number that occurs more than once. All right, it's going to occur over and over and over again. The B which is the initial fee, is the hiring fee. It only gets charged once, and that's 30. So X is balloon animals. Balloons. So 0, and then this is money. So if Fran, I'm jumping up past A, but if Fran has 0 balloon animals, she walks into this party. How much did she make if she doesn't want a balloon animal? Like if nobody wants balloon animals, how much is Fran going to get paid as a hiring fee just to walk in? $30. So if she makes if she makes 0 balloon animals, she still gets paid 30. That's the hiring fee. So let's back up to A, create an equation. We have the M of 0.50 and a y-intercept of 30. So it's y equals 0.50x plus 30. That is the equation of what Fran is doing here with the $30 hiring fee and a 50 cents per balloon animal. So if Fran makes 1 balloon animal, she gets paid another 50 cents, so it's $30.50. If she makes 2, she gets paid $31. If she makes 3, she gets paid 50 more cents. If she gets paid 4, she makes $32. If she makes 5, she gets paid $32.50. I'm going to stop there. You get the idea. So decide whether or not, decide if this equation represents a direct variation. I know that the M is 50 cents and the B is 30. It is not a direct variation. It does not go through 0, 0. The y-intercept is 30, so it's not a direct variation. No way, no. So y equals 0.50x plus 30. So we are going to put this into a graph. The initial value, let me look back up here. The initial value is 30. That's the initial value. I'm going to put that there as B equals 30. Because that's what she got paid right off the bat. If you look at the table, do you see the table? It's 0, 30. That's the initial value. This is, this right here is your y-intercept. X was 0. X equals 0. The other number is the y-intercept. So the initial value is 30. The M, I'm just going to put the M, is 0.50. Right? So, and really it should be over 1. But that's kind of like a little bit of a strange thing to graph. But let's go ahead and see if we could do this. So the X is usually time. But we're going to put balloon animals. All right. So we're going to put balloon animals, and I just, right there. So we're going to put 0, 1, 2, 3, 4, 5. Fran is busy. 15, up to 15 balloon animals. So whatever Fran starts at, you're going to start your graph at. So what did Fran, all the way on the top, what did Fran start at as a hiring fee? How much does it cost Fran to have Fran come and make these balloon animals at your party? $30. $30 hiring fee. So that means I'm going to go down here and I'm going to put $30 and I'm going to put money. Now, the next number, you're not going to jump up to 60. It's 50 cents per balloon animal. So that's my rise, that's my run. So the next number, if Fran makes one balloon animal, she'll make $30.50. And look, we put it in the table. See how it says $30.50? Then the next one is 31. Then the next one is 31.50. You follow that to make your graph. So you have 31. Sorry, not 31. You're adding 50 cents. So here we go again. 30.50. Then the next one is 31. The next one is 31.50. And you're jumping up by 50 cents because each balloon animal is 50 cents. And just like that, 33.50, 34. And this is money, so I'm leaving it rounded to the nearest hundredth. And it should go all the way up to 37. So now, we have balloon animals on the bottom, money on the side, money on the Y. By the way, this is the Y. This is the X. If you ever want to put that there, go ahead. They usually give it to you. All right, so what is the first point? When Fran makes 0 animals, 0 balloon animals, how much does she make? She makes $30. So we are going to go down. And we're going to say, all right, 0 balloon animals for Fran. She still gets that hiring fee of $30. Then she makes 1 animal. She gets $30.50 and 50 cents, the rise of 50.50 and the run of 1. And this is basically what you have. Just like this, the rise of 0.50, the run of 1, you go ahead just like this. Remember, this is not a direct variation. It starts at 30, does not start at 0, 0, and it's y equals 0.50x plus 30. And the reason why you have that 0.50 is because we're talking money. Talking money, we're graphing it, and that's it. This is not a direct variation. It does not go through 0, 0. And that is it. All right, so go ahead and see if these functions are direct variations. They're also called proportional relationships. Let's see if you could just look at them and identify whether or not they're direct variations now, and then we'll go ahead and solve them and then see what the y-intercept and the slope are, because that's very important as well. All right, go ahead, try all of these problems, solve them, give the slope and the y-intercept, solve them, and then we'll come back and look at your answers. Hopefully you got them right. Press pause and try the problems now. So be careful, right? So we know that y equals mx plus b with a b that is not 0 is not a direct variation. If the b is 0, that means it is a direct variation. So looking at this, you have 5x plus 2y equals 0. I think this is a direct variation. And if you go ahead and solve this, which is what we want you to do, just remember, we want you to be able to solve this in kind of like, without even thinking about anything about what you're doing there. We want you to be able to solve it pretty quickly. cancel out. You have 2y equals negative 5x, and you should be able to get the slope and the y-intercept based on what this is. It's y equals negative 5 over 2x. So the slope is negative 5 over 2, and the y-intercept is 0. That is why it is a direct variation. I'm saying this is not a direct variation, so you're subtracting the 5x on both sides. You have 2y equals negative 5x plus 9. When you see all three numbers that, and not one of them is 0, you know that you have, it's not going to go through 0, 0. You have a y-intercept that is not 0. You have negative 5 over 2x and then plus 4.5. So the slope is negative 5, and by the way, it's negative 2.5. And then the y-intercept is 4.5. Not a direct variation. So far, I'm 100%. This is a direct variation. You have only y and x. So to solve for y, though, you would have to divide by 7. You get y equals 2 over 7x. So you have a slope of 2 over 7, and you have a y-intercept of 0. Is this a direct variation? Yes, it is. Take a look at 3y plus 4x equals 0. We have this right here. We're going to subtract the 4x because we need to get the y alone. And this is 0 right here, so that's why I'm saying it's a direct variation. When you're dividing by 3 on both sides, you're not going to have a y-intercept of anything but but 0. So we have 4y. No. 4x, negative 4x, and then you divide by 3, and you get y equals negative 4 over 3x. So the slope is negative 4 over 3, and the reason why I said it was direct variation in the first place is that the y-intercept is 0. The last one, which is e, I'm going to say the same thing. You see this 0 here? I'm going to say it's a direct variation. So we're going to solve for y. That's 7.5x plus 7.5x. This right now gets, throw that out there. This cancels. You have y equals 7.5x. You could put plus 0 if you want, but it's not necessary. So b equals 0. Here's the direct variation. So everything I said, just taking a look at it, is correct. So when you see a 0 somewhere that is right there equals 0, that's a telltale sign that is a direct variation. When you see 3 numbers other than 0 when you solve, you know you're going to get a y-intercept of something that is other than 0. When you see just 7y equals 2x, that's another sign that it is a direct variation. All right. And so now we're just going to have to identify direct variation from a table of values. So there are some easy tables that you can look for, and there are some more difficult tables that you have. So let's just look at this first table. The first table is nice and easy to kind of look at. Do you see this 0, 0? Yep. So right there, if this is linear, that means it's a direct variation. All right. So far we're good here. So just remember, when you're dividing the y and the x, and you get the same number, the same constant throughout the whole thing, and it crosses through 0, 0, it's a direct variation because this is a proportional relationship. So let's go ahead. 10 divided by 5. So 10 divided by 5 is 2. You don't do 0 divided by 0. All right. 20 divided by 10 is 2. 30 divided by 15 is 2. This is a direct variation. And if you really want, this is the slope, the K, the M. The only time you could figure out slope that way is when you have a direct variation. If you don't, then this slope thing doesn't work out. You have to do y2 minus y1 over x2 minus x1. All right, so we could say that this equation right now is y equals 2x. It's y equals 2x because the slope is 2. Look, if you do y2 minus y1, 20 minus 10, and over 5, 10 minus 5, that's 10 over 5. 10 over 5 is 2. All right, so you could still work it out, y2 minus y1 over x2 minus x1, but you don't have to. So here we go again, hours of and pay. So let's see. First off, it does not have 0, 0. So right there, we either have to work back to it or we're just going to have to figure it out. So let's just do let's see if these are proportional. So let's see if the same K, when we divide y and x, if we get the same constant. All right, so let's do 12 divided by 2. Okay, that's 6. 35 divided by 5. Wait a minute. 35 divided by 5. That's 7. You could stop there. I mean, I'm going on, but this is not the same constant. Is this a direct variation? We don't even have to work back to it. Not a direct variation. So when it's not a direct variation, we're going to say that the slope and the K really, it's not like you could try to do the slope of this, and let's just go ahead. And if we get two different slopes with two different points, so this is x1, this is y1, this is x2, this is y2. These are not in proportion with each other. So this is definitely not a direct variation. But maybe let's see if we can get the equation. And we could only get the equation of a linear function. Remember, if the slope remains the same, that's the only time you can get the equation, right? So let's see if we could get, it's y2, so it's 35 minus 12 over 5 minus 2. So we have 23, right? So that's 23 over 3. So I don't even care what that is. Let's just go ahead, x1, y1, x2, y2. So let's do that again. M equals, let me just push this down a little bit so I can get a little space there. 99 minus 56 and 11 minus 7. So 99 minus 56 is 43. And 11 minus 7, 8, 9, 10, 11, 4. Okay, so let's just prove it. 23 divided by 3 is 7.667. And then 43 divided by 4 is 10.75. It's not negative. It's an equal sign. These are not the same, so you can't get an equation. You can't get the equation. Find the equation if you can. If you can, you can't. Let's talk about this one. So K equals y over x. 8 divided by 2, 4. 12 divided by 3, 4. 20 divided by 5, 4. This is proportional. I'm going to say this is a direct variation. And I'm going to prove it to you either way. So do you remember, like, we're going to kind of work backwards, right? So if it goes from 2, if x is increasing by 1 here, if you take it back, what's the x that's before 2? Obviously, it's 1. So we're minusing 1. So if the x, when the x increases, when the x runs 1, this is plus 1, the y rises 4. You see that? 8 goes to a 12. So if it went backwards, what would, minus 4 be from 8? That would be 4. Then we're going to go back. What's the number that's right before 1? We're going to subtract 1 again, and we're going to get to 0. And then we're going to minus 4 again, and we're going to get 0. Look, there's the direct variation. You proved that it went through 0, 0. So let's see if we can get an equation now. Remember, the b is 0, the m is 4. You don't have to take the slope, because the slope is, when in a direct variation, you could just divide y and x and get the slope. You have 4, and b is 0. So what's the equation? Y equals 4x. That's it. All right, exit slip. We're at the end of the lesson, under an hour, which is great. Which equation represents a direct variation? Take your time right here and see if you can do it. Circle the one that you feel represents a direct variation. A direct variation goes through 0, 0. It has to have a b of 0. So the one that you pick must have a b of 0, and it has to be linear. It has to be linear. It has to be straight. It has to have an m of something, right? So let's talk about it. Which equation represents a direct variation? So let's just talk about this one, a. What's the slope of a? What's the number that's directly before x? That's 1. What's the other number? That's the y-intercept, -2. This is not a direct variation. Cancel it. What's the number before x here? Yes, it is 1. What's the y-intercept? Yes, it is 2. This is not a direct variation. Cancel it. D. Skipping C for a second. D. The slope is 2. So far it's linear. The y-intercept, 0. Direct variation, definitely. Now, if you're looking at y equals 2 over x and you're saying, I have no idea what that is, it's because that doesn't even represent a linear function, right? So there is no basic slope here. This is not linear. So if you were taking your calculator and you were graphing y equals, let me get that 4 out of there, y equals 2 over x, that is the graph there. And if you press graph, this is what you're looking at. You're not looking at a linear function. This is not linear at all. So just remember, a direct variation has to represent a linear function first off, and the linear function has to go through 0, 0. And so this is nonlinear, and it's the only one that is nonlinear. All right, all the rest of them are linear functions. And there's one linear direct variation, and that's this one. So D is your answer, and I hope that helped out. And we are done. All right, ask questions. Make sure that you watch the video as much as you can, and I hope it helped. Thanks for watching.